as the title suggests, I thought I'd do a kind of semi-technical intro to, really, I mean, what does this tech actually do? You often hear lots of claims of blockchain revolutionizing the world and so on, but if anything, under the hood, it's a lot simpler than I think a lot of people, kind of portray it as often. And I think a good way to do this is really go through the cryptographic primitives and what's actually the building blocks. And a good place to start is really signatures, which if you've ever talked to a cryptographer, they'll often go complain about how terribly named they are. Really what we're talking about is something closer to a wax seal. And if you've ever seen a wax seal, I mean, you've got the wax that goes on a letter, and you've got the stamp. And the way you actually make these things is you get hot wax, and you pour it on your letter, and you get your stamp, and you push it down in. And that seal, I mean, what is it preventing? Well, if you look at it up close and are an expert, you'll go compare one wax seal to another and look very closely and say, all right, does this have exactly the right indentations in the right places and so on? And when you're talking about, say, 1600s era technology, it was pretty difficult to go and replicate a stamp to make two different wax seals. So if you had a comparison to see, is this an authentic or not authentic one, you had a reasonable chance of deterring forgeries, deterring fake seals. Well, how does this really map to what we call digital signatures? I mean, essentially, if you've heard the term public key, your public key is kind of like the seal itself, your kind of sample that you go compare against. And your private key is really the stamp, the physical thing you've pushed into the hot wax. And then the signature itself is kind of the wax itself on the message. There's kind of your comparison. And when we get all kind of mathy about it, well, we start writing some equations. We say, the number k is our private key, the thing we keep secret. We can generate from that k a public key, and that's the thing we can send to everyone else. And then our signing function s, it takes that secret k, and it takes a message, and it produces a signature. And that isn't terribly useful until you look at the verification function. You say, well, verify takes the public key that we think is associated with, that identity, that thing. We take our signature and we take the message, and it spits out true or false, valid or invalid. So when you get down to it, well, what does it prevent? Well, if I have the right message, it'll spit out valid and invalid. Our fake message isn't valid. So the math guys would probably go stop there, and they'll say, all right, we're done. We figured out public key magic. We can now identify people. I mean, if you actually look into crypto, this is where you get a lot of complexity. I mean, how on earth do you map a number to a human being? But for the sake of this talk, I mean, let's just suppose the world is an easy, lovely place, and we can easily figure out what public key maps to what person. In much the same way, I'm sure the ancients actually had a problem figuring out, well, I know this concept like King George, and I'm supposed to go follow his instructions because I'm a statist. And I think King George's seal is like that one there, but I'm not actually sure it is him. I mean, how do I know that? I've never met King George. He's a statist. I mean, my job isn't to actually meet him. He's supposed to go rule over me, and I do what he says. Or at least I try to do what he says. I don't really know who he is, but. So there's your signatures. I mean, what are you going to do with a signature? Well, you'll get 1990s cypherpunk ideas of we're going to sign our house contracts and our employment contracts, and we'll go sell things with it, et cetera, et cetera. But there's good reasons why that didn't happen. And the next step in this is really, well, blockchains. And again, we have a great example of blockchain here, securing ballots in the Catalonian referendum. We've got a chain and a very heavy block. And I've heard they did a really good job at preventing this attack, where some statist comes in and tries to go steal the thing that your blockchain is being held onto. And that looks like a great security model, except of course that's physical and I wanted a digital magical thing. I mean, that blockchain looks like weighs a couple hundred pounds. So we'll again try to go and approximate this with some kind of digital thing, which is what we call a commitment. And I actually used one of these a couple days ago. Yeah, that's what, October 5th. And here I am, you probably can't even read that, but essentially saying, you know, I figured out some homework question exploit thing. I'm basically saying, I challenge you to go and find an answer to this, and my answer is this long hex string. Well, what was I actually doing there? I mean, in terms of the math, I used the SHA-256 function, and I took my message, which happened to be my answer to what I thought this exploit was, and I hash that, and I generate this commitment, which is that, you know, big hex string. And the key property of that is SHA-256 makes it very difficult to find two messages with the same commitment. And when I say very difficult, you know, that's kind of something like, well, if you had a computer that could do this, it would require you to, say, take all of the universe's matter and turn it into energy and run a giant supercomputer and so on. If the math actually works, this is not possible. The wonderful quote along these lines is Bruce Schneier, which says, for it to be possible to brute force AES 256 keys, similar thing to SHA-256, computers would have to be made of something other than matter and occupy something other than space. So if the math works, that's all well and good. And getting back to my original example, well, I'm saying I claim in advance that my answer will be this, but I'm not going to reveal you that answer yet. And now I'm constrained in the future. I've committed to it such that there's no other way that I can go swap that out. All right, so what about a blockchain? Well, I mean, a cryptographic blockchain is a chain of blocks. That's why we call it a blockchain. And that may sound kind of stupid, but I mean, let's go look at, well, what's actually going on. I mean, we have our block 0, which is that famous Genesis block, which I think the quote's something or something on the verge of bailout for, you know, the bank shit again. And I can get into actually why you would put a quote in that, but for our purposes, we can say, all right, that's your 0th block. And then for every block after it, well, we take the SHA-256 of the previous block, and we concatenate that with our actual data. Well, I mean, what did that really do? Remember my answer here? I mean, my answer is committing me to a particular message. But if that message itself contains another commitment, I'm also committing to the message prior to that. And if that message there contains another commitment, I've committed to the message prior to that. So you've kind of got this chain of data. And with that chain, when I go say one thing, I'm actually referring to everything prior to it. Well, and what's different then about, say, our signatures? I mean, the thing with the signature is it's kind of disembodied. It's kind of separate from other things. You know, a signature is like, I am making some claim, and you know the claim came from me. But that claim doesn't refer to anything else. You know, I'm saying this thing is true, but I'm not saying anything beyond that one statement. Well, where might this come into play? I mean, imagine if I'm selling you a house and you think I'm giving you a good deal and all and great price, and I sign off my contract, and being the cypherpunk that I am, I sign this digitally with my PGP key. Well, then you go find out, after you try to go move in, that this other guy called Bob, he's already living in the house, and he also has a signed contract with that PGP key. And now you got to figure out, well, who actually owns the house? You know, the problem with this is, well, the fake message is not valid. That's not the full story. The full story is I can make two messages that conflict, that have different meaning. Ultimately, in a sense, the signature system didn't constrain what I could go do, the guy who produced the signature. The signature constrained what the bad guys can do. Well, if I'm the bad guy, it didn't constrain me. Whereas in my commitment example, if I'm the bad guy trying to go pull a fast one and change what my commitment is, even I can't do that because I'm prevented from doing something by the math. In a blockchain, being a chain of blocks, well, once we say something about one block, we're prevented from changing the contents of prior blocks. The only problem is, how do you go pick which is the tip of that chain? Where are we? Oh yeah, sorry, a bit out of order there. Well, we have this mining thing. And if you've ever heard the scare stories, mining probably consumes all of Japan's industrial output and destroys in a giant orgy of excess consumerism or something. But, quite simply, we're destroying energy. But we're destroying energy in a very particular way, which is we're destroying energy in a way that commits to data. Well, we already showed how to commit to data before, but how do you commit to data with an identity? In my Twitter example, if that tweet didn't come from me, why would that commitment mean anything? It's just like the signatures. An infinite number of anonymous eggs on Twitter can go and commit to things, and it's all meaningless because there's nothing distinguishing one commitment from another. If I wanted to make 5 different predictions for potential Bcash exploits, I could go and make all those different predictions and only reveal the one that actually came true. Well, with Bitcoin, we have that same problem, because in Bitcoin, we want this to be a decentralized currency. We don't want to have identity controlling it. And that's why we use Hashcash. And I'll try to avoid making Adam back here notice I'm talking about Hashcash, because he kind of invented it, and he'll probably go say how wrong this explanation is, but this is essentially what Bitcoin's doing under the hood. It's saying we have our block, the actual thing in the block, and we hash that. And then we also go hash that commitment with a nonce n, and we try to make that number coming out of all that be less than some target. Well, let's think back to what does a commitment need to be? If a commitment's predictable, in the hash digest case, it's not a very good commitment. So it's essentially like lottery tickets, where every time I crunch the numbers with a new nonce, it's like I'm getting a lottery ticket. And if that target is sufficiently small, crunching those numbers to go and check this nonce is actually quite hard. That bank of miners you see here in this kind of blurry Creative Commons photo, that's probably checking, I don't know, 1 billion or something per second. 1 billion nonces per second, trying to go find that one nonce that's valid. And in Bitcoin world, globally, I think the current target's like 1 over to the 64th power or something. It's a very, very, very small number compared to the total key space. So very few attempts actually work. But when they do work, we now have a block in a blockchain that we knew was very difficult to get. And to make another one like that is tough. I'd have to redo all this work. Which gets back to double spending. I'm the guy buying something. I'm trying to go buy it from a seller, and I give that seller my Bitcoin. Well, this is just like the house all over again. If I manage to give that same Bitcoin to 2 different people, I've defrauded them, because Bitcoins aren't supposed to be inflatable, right? There's only supposed to be one Bitcoin. It's only supposed to go to one buyer. Or sorry, one seller. Well, part of this we already seen we can solve with the signature. I go sign where this Bitcoin's going. But by putting this data in a blockchain, we now have a a way to define what's a full set. And if we make the rule be, well, you're not allowed to send the same Bitcoin to 2 different people, we've now prevented a double spend. And now then if we use something like mining to make it difficult to create 2 parallel blockchains, well, not only have we prevented a double spend at that level, we've prevented a double spend at the Bitcoin level. And with that, that's really how blockchain works. Now, I get the feeling there's probably going to be some questions.
So, thank you, Peter. Hello, hello. Can you hear me? Oh, you can. So thank you, Peter, for the brief presentation about the blockchain and mining basis. So, do you have a question? Yeah, there are questions from some beginners.
So do you think proof of stake is possible at all?
Well, so kind of where we left off there was we have mining and we destroy energy to go make something unique. Well, if I have a digital signature system, and I go sign something, I mean, what else could we do to make that unique? Well, you can imagine if my Twitter account was, say, signing Bitcoin blocks and saying, hey, I think the next step in this Bitcoin block should be whatever. I mean, what would happen if I made 2 different statements at once? Or maybe even more concretely. I mean, if I'm the guy selling that house and I try to sell 2 different houses to 2 different people, or sorry, 1 different house to 2 different people, well, what are you guys going to do when you find that out? You're going to go say, well, Peter Todd is a fraudster. Here's the proof. We have 2 signatures for the same house to 2 different people. And that's very solid proof that, I'm a fraudster. And the idea behind at least the most sophisticated proof of stake implementations, proof of stake concepts, is that we leverage this proof of fraud to say, well, now you no longer have the right to go sign for this thing. The problem is, nothing actually prevented that fraud directly. We're preventing it indirectly. In the case of mining, we prevented it directly by saying, well, to do that fraud, you actually have to destroy a ton of energy. And this is obviously expensive. It will always be expensive. There's no shortcuts. In proof of stake, there is a shortcut, which is if I can defraud one person and other people don't learn about it till it's too late, I do get away with the fraud. And long story short is we call this the nothing at stake problem. So to answer your question, I mean, can we go and use proof of stake? It depends on your security model. Can we use PayPal? It depends on your security model. I mean, if I'm just, trying to go buy something online and I don't think I'm going to get censored, I don't think I'm going to get attacked, I probably will go use PayPal because that often goes and works. And my security model in that case is PayPal is okay. If I'm sending anonymous digital cryptocurrency around, I'd probably be a bit more dubious. If I'm using proof of stake, now people have incentive to attack my internet connection, to censor me, to prevent me from telling other people about the potential fraud that happened. And in practice, I mean, there are proof of stake chains out there, and so far, the ones that have actually been deployed, they've tended to break down because of these nothing at stake problems, where I can create multiple different versions of history, and you can't distinguish between each one any more than you can distinguish between me selling the house to Alice and me selling the house to Bob. Both actions are valid. It's just doing them both at the same time isn't. Well, what happens with these proof of stake implementations? The reality is that so far they all end up using developer signed checkpoints, and that distinguishes between those 2 possible histories. Now, does that mean that something like Casper will succeed in the future? If your security model is sufficiently weak, it probably would work just fine. But I suspect as this stuff gets deployed, we're going to see some big attacks. Yeah, and that's going to come out of this nothing at stake problem. So,
Hey, Peter. So we've already had 2 months of Bcash. Where do you think that project's going? And what are your thoughts on the upcoming attempt of 2x? And what do you think is going to happen there?
well, I mean, show of hands, suppose I have 5 Bitcoins, and obviously I'll have 5 B2X tokens. Who's willing to do a one-to-one trade with me? I'm not seeing any hands. Well, I'll give you the B2X as a one-to-one trade for Bitcoins. Oh, no, I want more Bitcoins, yeah. Just to be clear about this, I want Bitcoins in exchange for that B2X. So do I have anyone willing to take me up on this trade? All right, what about the other way around? What if I go and give you Bitcoins for the B2X tokens? I mean, yeah. So I think that probably answers your question. And, you know, quite seriously, I mean, I think the real issue here is that you've yet another attempt to go and redefine what Bitcoin is, that not many people seem to be interested in, and it's on the heels of another attempt, namely Bcash, which had much the same goals, and actually happened, and is actually out there, and you can actually go buy it, yet no one seems to be very interested in it. And, you know, if I'm a user, I mean, what am I going to look at? I'm going to look at, well, is this new coin going to be something that developers actually work on? I mean, all right, so what, there's Jeff Garzik and Jeff Garzik, I guess. A little, but he's not doing much, you know? Like, their team is just small, and no one seems to be interested in working with them. So let's face it, you know, cryptocurrencies aren't perfect. They do rely on a bit of trust. You know, they do need someone to push the tech forward. And if I'm buying into something that no one's interested in, I mean, I, by myself, even me personally, you know, let's not talk hypothetically, like, actually me personally, I know I'm not good enough to go push, say, B2X forward if I were to go buy it, all right? But someone has to. So if I'm not buying into something with that team, I mean, I'm probably not spending my money wisely. You know, similarly, if I'm buying into something that's getting pushed by people with all kinds of incentives, like, well, big blocks can mean that other miners have a harder time getting that data and so on. That's a very dubious thing. So, yeah, I mean, I think there's lots of issues why this isn't going to happen. And I think from their point of view, the main strategy they have, you know, the B2X side has to make B2X happen, ultimately kind of looks like fraud. You know, if I'm selling something and I claim it's Bitcoin, like Bitcoin.com claims, you know, claims they'll do. Well, if I say it's Bitcoin, but it's actually B2X, and most exchanges in the world are listing it as B2X, I'm sorry, but that's just straight up fraud. You know, I'm selling something that it's not. You know, same thing with this replay protection. If I'm setting users up so that it's likely that their wallets will trade something that, or accept something that they didn't think they were accepting, that's fraud. You know, that is making fraud possible. And even just that alone is enough to discourage developers. You know, even if I did like B2X, I personally would be thinking, well, why do I want to go work on a project that's looking like it's going to result in a lot of fraud? You know, God knows what the hell the SEC or the FBI or whatever are going to think of that. I mean, that's an actual legal risk. And if I were on that project, I'd be shouting left, right, and center, let's make sure we get rid of these legal risks. You know, let's make sure we get rid of these ethical risks. But none of that's happening, so it's no surprise no one wants to buy my B2X tokens.
Hi, Peter. Thank you for your talk. So I think that you are trying to argue that a blockchain is a chain of blocks. Now, it's very clear to me after your presentation why it has to be a chain. So basically in a hash chain, a chain of commitments, but still not very clear why it has to be a chain of blocks. Can it be just a chain of single transaction like in a Tangle or like in IOTA or UTA? I asked this question because I think it's relevant for private blockchains. I mean, if you don't have stuff like problem with network propagation and you are in a closed environment, you probably don't need blocks. Is that right?
Well, I mean, when we look at my lovely little math equation there, where did I actually say what a block was? You know, and it is easy to imagine systems where a block is one thing, like one transaction. And in fact, this is kind of the wrong audience to make this joke, but let's assume for the sake of argument that this was a fintech conference and you guys were all a bunch of 70-year-old bankers who had recently got, you know, say an Apple-like iPhone, and, you know, their assistants were helping them use it. Even in that circumstance, most of the people in that audience would be using a blockchain every day. And the reason why is something called certificate transparency. And what certificate transparency is basically a blockchain for HTTPS, you know, SSL certificates. So when I go to, say, you know, my large US incorporated evilbank.com, when that green bar pops up, or at least it would if they were competent, it probably won't in reality, but if they were competent, it would go pop up. And I'd be able to go click on that and say, all right, you know, why does my computer think that that connection is to that bank? Well, the way it ends up doing this is, of course, with an SSL certificate. But the key thing is the SSL certificate is then forced to be published in a blockchain. Google and a few other providers run those blockchains. They're signed. But what my browser is getting is a proof that that thing happens to be in one of those blocks. And that particular, you know, the way that block works is just one SSL certificate per block. And just like the blockchain was shown here, they refer to the previous block and so on. But the important thing there is that it is a canonical place. And because of the nature of blockchain, you know, I can go start at the tip block and work backwards and say, well, I don't have the data for this commitment. All right, where do I get it? All right, I've got that. How do I get the data for the next commitment and so on? And the moment I run into, hang on, I don't have the data there, that's where the fraud happens. In the case of an SSL cert, that's how a man-in-the-middle attacker would create a false SSL cert and not have that detected by, for instance, the bank. Well, that particular type of blockchain, Google Chrome supports it. I think Google Firefox just added support, if I remember correctly. I mean, long story short is this is getting very widely used. It is a blockchain. Every block has one thing in it. Sure, it's signed by Google, but it works and it's very successful. So to answer your question, yes, absolutely you can do that. The other thing is, I mean, why does it need to be a linear chain? You know, there's lots of systems where your chain could branch. I mean, yes, it's not necessarily called a blockchain at that point, but you know, when you look at a transaction graph, I mean, I send you bitcoins, but those bitcoins came from multiple sources. You can imagine a reworking of Bitcoin where that chain is actually a directed acyclic graph. You know, I actually directly commit to where that money came from, and you can imagine the proof of work committing to that as well. And Ethereum's proof of work algorithm actually kind of works a bit like that because of the idea of uncles and so on. So yeah, I mean, this is definitely an idea, and frankly, you know, blockchain is probably not the right data structure for a lot of problems, but they're easy to understand, so.
Thank you, Peter, for your talk. It was a very concise explanation of what the blockchain is compared to like, I think there was a tweet something along the lines of like, if you watch a VC explain what a blockchain is in a post, it's a little bit like watching a 5-year-old explain what their parents do for a job. So that was a definitely refreshing explanation. My question is about the word blockchain and how, I mean, I like words because you can like convey ideas and talk about them, unless like both people in a conversation have the same definition of the word, right? But like the definition of the word blockchain has like become pretty much meaningless at this point. At least that was my feeling. My question is like, how can we get that back? And the second part is when I studied Bitcoin and the past of it a little bit, I discovered a source code leak of the November 2008 source code, And interesting part is like, so the first time somebody used the word blockchain was actually in the main.h file in the Bitcoin source code. But in the November leak, that word didn't show up. Instead, Satoshi used the word time chain.
Yeah.
Any idea why he changed that, in your opinion? And what would the word look like if we were only talking about and going all to like time chain conferences?
Well, I mean, the actual term blockchain, someone else can probably go dig up the exact reference, but I've heard of it being used in academic papers, you know, even in the early 1990s. And it's not really surprising that would. I mean, if you have a chain of things, which is a natural cryptographic structure, you might call those things blocks, and then you call it a blockchain. You know, this is not a particularly hard term to come up with, and it's something that you'd reinvent many times over. So, yeah, I mean, that's kind of a natural thing. I think where the confusion comes in is really that people are looking at these sort of promises of what you would do with the so-called blockchain tech. And those promises end up being not really based on fact, you know, not really based on solid, concrete ideas. You know, when you, for instance, look at the early Ethereum offering, you know, not even called an ICO back then, but essentially the early Ethereum crowd sale, so the marketing material would talk about things like, you know, using it for hotel locks, or, you know, using it for decentralized Tinder or whatever. Which I got pitched on apparently yesterday, although I kind of half forgot about it. But, yeah, this is why, like, I always go to, well, what are we actually trying to prevent? You know, what is the thing we're really doing? Because after all, this is security software. Normal software lets you do things. Security software annoys people. And it annoys people by preventing them from doing things. Hopefully the attacker, but often the good guys too. But either way, I mean, you got to start with that design criteria. And unfortunately, most blockchain tech enthusiasts don't do that. You know, they talk about, well, we're going to make decentralized Tinder. All right, that's all well and good. What is being prevented here? Well, from what I gather, decentralized Tinder prevents me from forgetting about the fact that 99.9% of my matches never went anywhere. That's not something I really want to prevent. So yeah, decentralized Tinder doesn't make any sense. You know, not with a blockchain anyway. But you can imagine, like, people kind of see this tech and they get ideas about it. The other half of it is that people, I think, kind of forgotten what a cryptography is. You know, when they see these use cases of cryptography that look all exciting, well, people start thinking that all of cryptography is this. You know, this is why my Twitter profile says I'm an applied cryptographer. You know, I'm some guy with a fine arts degree who goes and takes crypto, which is not that hard to understand once you know, put into building blocks, and applies it to actual problems. And that's what blockchain tech is, and a blockchain just happens to be a particular solution to a certain class of problems. You know, most of the problems we have are actually much simpler. I mean, how do you know this email came from me? Well, because of a digital signature. I know maybe we'll put a blockchain in there somewhere, but that's not, like, first and foremost what you should talk about. You should talk about the cryptography. So, you know, how do you get people away from this? I mean, I think you just got to be consistent in your terminology. You know, say what you're doing is crypto. And as for Satoshi talking about time chains, well, that's kind of a pet peeve of mine, which is people talk about timestamping rather than, ironically, blockchains. You know, why that's a pet peeve of mine is, well, a time chain, that makes it sound like the thing that matters is the time that the things in the time chain, you know, get committed or get added. But, you know, my house example, well, all you cared about was the relative time between those two sales. And the only reason you might care about that is the law will probably say the first one is the real one. But in any sane system, what matters is first or second, not exactly when. Because after all, I mean, if I walk sufficiently fast, my notion of time is radically different than yours. I also start aging younger and star in a bunch of sci-fi stories. I mean, quite frankly, like, it is a physical fact that we can't really talk about time concretely, but we can talk about order, and order is much more useful to talk about. And that also means that when people say, for instance, that the blockchain timestamps things, again, that's just incorrect. My pet project, Open Timestamps, it timestamps things just great. Does it mean that a timestamped house sale gives you any real security? Basically, no. Because the timestamp just says when something was done, not if there's conflicts. So from that point of view, yes, the blockchain is a great term. It's a much better term than a time chain. And I'm actually kind of glad we got the blockchain terminology as abused as it has been. Because at least then I can say a blockchain is a chain of blocks, and you can figure out what's in the blocks, and you can come to consensus over it.
Two quick questions. First, are there any reasonable cryptocurrencies apart from Bitcoin that you find worthwhile to investigate? And the second one, do we have any idea how to implement decentralized routing for Lightning Network?
Well, in terms of reasonableness, I mean, first of all, a lot of them just copy Bitcoin. So in a sense, obviously, they're going to be reasonable. I mean, Litecoin's basically a clone of Bitcoin. So modulo the fact that it's not Bitcoin, it's perfectly reasonable implementation. And something like Zcash, I mean, it certainly adds interesting capabilities. So from that point of view, yeah, it's kind of reasonable. I think the problem there is that if you're investing in one of these currencies, we can also add those features to Bitcoin. We can add them either in a federated chain, or we can, in a sense, add them by just using Zcash and buying some Zcash, selling it again, and getting anonymous Bitcoins back. So really your question there is about how do you not just have a reasonable implementation, but how do you get the mind share? And I think that's just a standard problem where in something like currency, where there are very strong network effects because I don't want to have to buy multiple currencies, you're always going to have the most reasonable thing be the thing that everyone else uses, so long as it's not all that bad. I mean, Bitcoin itself, let's face it, if there was some way to get US dollars into the digital realm in a secure fashion that was censorship resistant, et cetera, et cetera, et cetera, I think it would outcompete Bitcoin in a second. Because for most use cases, what we want is a thing that we can securely move money around and store money that isn't vulnerable to censorship. Now, for a subset of the use cases, they want it to not be vulnerable to, say, inflation. But for a lot of use cases, I would much rather not have the exchange rate risk of Bitcoin, because that's not what most of my expenses are priced in. Same thing as if we could somehow digitize gold, and send gold digitally in a secure way that didn't have counterparty risk. Absolutely would outcompete Bitcoin, because then it would have that non-inflationary part, plus it would have the digital part. The only reason we wound up with a different currency for Bitcoin is I, for the life of me, can't figure out how on earth am I going to digitize gold without counterparty. If you have any clever ideas, please tell me. It's probably just can't be done. And that's why we end up with separate currency. But once you have one currency, where are you going to add another one? Adding another one is just inconvenience. If I want to use Zcash, given that most other people are accepting Bitcoin, I'm now going to buy Zcash and then sell Zcash. And now I've done 3 transactions, rather than just one. It's not really what I wanted to go do. So, I think that kind of answers your question there. And in terms of reasonableness, I mean, could Zcash be the most reasonable thing? Sure, if everyone was using it. Now, Zcash happens to have some other issues, like the trusted setup and so on, but for sake of argument, let's assume that technically it's roughly the same thing. Then it's purely a mindshare thing. And Litecoin's certainly in that position, so.
Yes, and there was another question, I think, about if we can build the Lightning Network in really decentralized Lightning Network.
Well, I mean, what do you mean by real decentralized?
I mean, the routing in, is there any idea how to do decentralized routing in Lightning Network?
I mean, the decentralized routing thing, depending on what kind of scalability you want, that's a very easy problem. because every Lightning channel gets associated with the Bitcoin transaction output. The problem of routing will never be any worse than the problem of having copied the UTXO set times some fixed constant times some amount of some amount of coins, some amount of overhead per coin. So concretely, if you imagine, say, every Lightning channel is associated with, say, a kilobyte worth of state, well, if we just propagate all that stuff around, I think right now we've got, 25 million UTXOs or something like that. Well, 25 million, 25 gigs worth of data. It's not that bad. It's not great, but it's not that bad. And with that amount of data, we'd be able to scale Bitcoin, many times more than it is right now. Is that sufficiently decentralized? I know I'd like to do better, but I think the basic answer to that question is yes, it's quite plausible we'll have decentralized routing, and it doesn't look much harder than before. It's not necessarily the best implementation. I mean, the flood fill aspect of that kind of is stupid, but it works. It's a potential prototype. I think the more interesting question is, if your notion of decentralization is being in a position where, Lightning hubs, in a sense, like Lightning channels with more capacity or less capacity than normal, don't exist and everything is equal in that way, that's, I think, when you can make a decentralization argument, and you're going to probably go toss out Lightning and replace it with something radically different. I'm trying to go work on stuff like that with my work on Proof Marshal to find a way to send proofs from one person to another and rate these kind of applications. You may have heard of my tree chains idea, but that looks nothing like Lightning, and whether or not I can actually make that tech work is frankly an open question.
I would like to ask if you think that we can do without the blockchain. Recently, I saw your opinion on MadeSafe on Twitter. MadeSafe is trying to build a distributed network where small deterministic groups of nodes are processing everything on the network. And on Twitter, you said that you visited their office and they wasn't able to convince you. So what was you are worried about exactly, and why they are not able to solve it?
Well, so when we're talking about decentralized file storage, there's really two fundamental problems. And the first one is, if all you want is to have at least one extra copy of your data to exist, a decentralized file storage system can easily provide some assurance that's true. And the reason why that is I can create a protocol where to earn money within the protocol, I have to go prove I have a random sample of some subset of data. A subset of some set of data. And that's feasible. I can do this with Merkle trees. I can commit to a tree of all the data I have, pick random samples, and with a bit of stats, figure out how likely is it that they actually had that full set. Now, this is quite well understood. The problem is that type of proof did not say whether or not two people had that data. Did not say whether or not that data was stored in a fashion that wasn't vulnerable to, say, a flood, for instance. And where that becomes apparent is, well, let's do a thought experiment. Let's suppose that we have such a system. We might call it MadeSafe. And some young intern gets hired by Google, and they don't really have a project for him, so they kind of leave him alone in his office for the rest of the summer. And he has the bright idea, well, Google's got a lot of spare hard drive capacity. Let's go run a whole bunch of MadeSafe nodes. And let's go earn some money on this. And he does this for the rest of the summer. Google, having a lot of hard drive capacity, provides a big chunk of the storage space for MadeSafe, potentially nearly all of it. At the end of the summer, his manager realizes that they've ignored their intern for the past 6 months, and oh shoot, what were you doing? Oh, I was running MadeSafe nodes on Google. Yeah, you're fired. And they shut down all these nodes. Well, from the point of view of the user of MaidSafe, how did they distinguish that from 10,000 people running different nodes? The reality is they can't. In a proper decentralized network, you can't distinguish that case from the case where your data is actually decentralized, stored in a decentralized way. Similarly, if I want to know, does there exist 2 copies of my data in the network? Let's ignore, who runs these 2 copies. Let's just say there are 2 copies. Well, I could use the speed of light. I could say, well, if you can reply to a ping for that chunk of data in less time than it takes for data to get around the world, I can narrow down where that data might be. But how do you do that in a decentralized way? The reality is you can't, because you can't say where the nodes doing the verification actually are. It's the same problem all over again. So from that point of view, yeah, they never did convince me that they could provide any more redundancy than just maybe having a copy of data somewhere. Whereas what they were trying to claim was that it would be highly reliable storage. Unfortunately, that's just not true. The second part that they didn't convince me of was, and this was a lot kind of more fuzzy and they didn't really explain things terribly well, but they seemed to claim that you could have currency without having consensus. And it actually goes a little beyond, I think, your question, like, currency without a blockchain. I think we can do currency with just commitments, and it's not a blockchain per se, but to have currency without consensus, that's nuts. And it's like, going back to my house example, you just somehow assuming that people are honest or something. I mean, how do you go and enforce a limited supply if you don't have consensus over that limited supply? Equally, if you do have consensus over that limited supply, well, now you have scalability problems. And now you have all of Bitcoin's problems all over again. And more generally, I think this is a big problem with most ICO tokens. The moment you add a token to your project, you now have to have consensus over that token. And with current technology, consensus over that token doesn't scale. Therefore, you've just taken your protocol, which might have been really cool, and made it not scalable. I can't really recommend that as a good idea. And unfortunately, I think MaidSafe, they recognize that. They did the thing that would work, except why would you ever invest in a token that can be inflated? So, I don't know, maybe they've come up with something new since then, but when you're talking about a project that started in like early 2000s and still hasn't produced results, maybe it will never produce results. Currently I'm just not convinced that it will.
Okay, thank you. And last question.
So, favorite punk rock person in the space, DeSantis, put out this thing about how theoretically, basically, every block could fork. And so we get into the idea of derivatives and derivatives of derivatives. Do you see the possibility that ICOs, as they're presently done with individual tokens, could be done on forks, so consensus individual forks of the existing chain?
I mean,
in other words, that nothing's happening anywhere else but essentially on the mother of all chains.
Like, a statement like that kind of annoys me because it's not really all that precise. When you're talking about, say, a fork.
Very fuzzy, a lot of hand waving, I agree with you. But let's spit it out actually.
So let's try to maybe come up with, the term that's used often, steel manning. Let's take the best version of this argument. And if what he means is, can we have a system where, we do a fork as a way of doing our ICO, I think you've got some pretty obvious consumer issues, which is that, why am I going to go use this complex system that requires all these complex tokens that I can barely describe when I could just use a normal application? And I think that gets back to my other issue with ICOs, which is they'll probably get outcompeted by simpler solutions. My own project Open Timestamps is, I think, an example of that, where timestamping is a sufficiently simple problem that I can probably go do it for free, with development funded by donations. The service can be offered for free. Heck, it's so simple. Service can be offered for free, even though it's kind of centralized. And if you're an end user looking at, well, am I going to use that, or am I going to use Tyrion, which sort of seems to require me to buy a token? Why am I going to choose the latter when I can just install something and use it? And Tyrion, to their credit, I think they recognize that, which is that they expect making timestamps for their system to be free for the first year or two. All right, well, that's all well and good, but then again, remind me, why did I go buy that token? I mean, where's the demand part of the supply and demand? I see lots of supply. I see Tyrion nodes getting injections of Tyrion tokens as a reward for being run, but where do you actually go buy the thing? You know, until you have that use case where you go buy it, why do you have a token? So, you know, I think that's more the bigger picture answer. I mean, all fuzziness aside. Yeah. Thank you.
So thank you, Peter, for the presentation and very interesting discussion.